Okay, in this video, we are answering the question, what's on tomorrow's quiz, on Friday's quiz? There's going to be rate problems, which are things like the DRT, the distance, rate, and time problems, the job problems. Those are the, people working together, pipes, hoses, cars, airplanes, all trains, those kind of things. There's variation, and in variation, we did two different things. We did computational problems, where it was just a X and Y, and they vary, and here's X and here's the Y, solve for it. The other were applications, where there were actual things, some situation. These were in the textbook. They as Hooke's law would state, and various things would be going on, and those are applications. So I want you to be able to think about being able to write your own application, come up with some situation of something that varies for the quiz tomorrow. Be able to write one yourself. So the distance, rate, and time problems, remember there were three different equations: d equals r times t, or r equals d over t, or d equals d divided by r, depending on what you had in common. Then there were the job problems. We had things like two people painting a room, or two factories making a product, or the hose and the pipe filling the pool, those kind of problems. You can look back at those videos to find some examples of all of those things, both the distance, rate, and time problems and the job problems. The other type of problem that that will be on the final, like it says over there, is variation, and this is like a computational one. Y varies directly as x when x equals 10, y equals 6. Find y when x equals 12. And you could write that down and work on it, and I'll have the answer in a little bit for you, but let's look at something else here. The other was the application problems, where there'd be some sort of situation. So here's a situation. How long it takes to make a video lesson varies inversely with the number of lessons I have made, meaning hopefully as I make more of these, they will take less time. So that's that situation of inverse, increasing number of videos, decreasing time it takes to make a video. Now I'm just making up this information, so this is my making up a variation problem. So I'm just making up this data. It says after 8 video lessons, it takes 76 minutes to complete a video. So predict, if that were true, if all of that were true, predict how long after I have made 30 videos, how long it would take to make a video after I have done 30 of them. So this is my made up situation. You can write that information, pause this video and try to work them out, because in just a moment we're going to go to the next page where the answers are to the problems. So here is the beginning of the first variation, the computational variation problem. We've got 6 equals k times 10, since it was a direct variation problem. We solve for k, which is, of course, the constant of variation. We then use that to write the equation y equals 3/5 x, which is, of course, the equation of variation. We then plug in that second piece of information, was when x equals 12, what does y equal? And there we have it, y equals 36 over 5, which is the final answer. Now let's look at the situational problem. I said that time varies inversely as the number of videos, and so I've got that there, and I'm even telling you what t and n stand for. And so then I plug in the data that was given and solve for the constant of variation. Now, using that constant of variation, plug it back into the equation to write my equation of variation. Plug in the information that was given. What about after 30 videos? So now we just simplify, and we get 20 over 20 and 4/15, which means, remember, this is a situation, so it should answer in a sentence, that after 30 videos, it should take 20 and 4/15 of a minute to make a video. Of course, remember, that data is all made up. I'm just showing you that I can make your own variation, and so you should try to come up with one as well.